Picture this: you're soaring peacefully at 37,000 feet above the vast Pacific Ocean when suddenly, both engines go silent, the cabin lights flicker, oxygen masks drop, and the captain's ice voice crackles over the intercom with words no passenger ever wants to hear. Prepare for an emergency water landing. This terrifying scenario, known as ditching, represents aviation's ultimate test of human skill versus nature's raw power. While commercial flying remains statistically safer than driving to the grocery store, with only 7 fatal accidents occurring in over 40.6 million flights worldwide in 2024 according to IATA data, the possibility of ocean ditching haunts every transoceanic flight. When conventional emergency procedures fail, and no runway lies within reach, pilots face an impossible choice: attempt a controlled descent onto an unforgiving ocean surface that can behave like solid concrete at impact speeds. Historical precedents of survival aviation history records only a handful of successful ocean ditchings, each one a masterclass in crisis management under extreme pressure. The most remarkable occurred on October 16, 1956, when a Pan-American Boeing 377 Stratocruiser experienced catastrophic engine failure over the Pacific. Captain Richard Ogg executed a textbook water landing, and against all odds, every single soul aboard. All 31 passengers and crew survived the impact and subsequent rescue operation. More recently, the world witnessed Captain Sully Sullenberger's legendary performance during U.S. Airways Flight 1549 in January 2009. Though technically a river landing rather than an ocean ditching, Sully's split-second decision-making resulted in all 155 passengers and crew surviving without a single fatality. This extraordinary achievement demonstrated that controlled water landings, while extraordinarily challenging, can indeed result in miraculous survival stories when crew training, equipment, and circumstances align perfectly. The science behind water impact. Understanding why ocean ditching is so perilous requires grasping the physics of water at high speeds. When an aircraft traveling at 150 knots strikes the ocean surface, water doesn't compress or yield like you might expect. Instead, it creates tremendous resistance forces that can instantly decelerate the aircraft from highway speeds to zero in mere seconds, generating G-forces that can be fatal to human occupants. The key to survival lies in approach angle and sea conditions. Pilots must align their aircraft parallel to ocean swells, rather than perpendicular to them, as hitting waves head-on creates catastrophic stress on the fuselage. Additionally, the aircraft's configuration becomes critical. Flaps extended for maximum lift and drag, landing gear retracted to prevent nosediving, and auxiliary power units engaged to maintain essential electrical systems during the final moments of controlled flight. Modern safety systems and prevention. Today's aviation industry employs sophisticated prevention measures specifically designed to avoid ocean ditching scenarios. Extended range twin-engine operational performance standards (ETOPS) regulations require twin-engine aircraft to remain within specified distances of suitable airports throughout their oceanic journeys. These rules ensure that even with single-engine failure, pilots can safely reach an alternate landing site rather than attempting a water landing. Flight planning software continuously calculates fuel reserves, weather patterns, and emergency diversion routes for every transoceanic flight. Modern aircraft carry advanced communication equipment that maintains constant contact with air traffic control and search and rescue coordination centers. Additionally, satellite tracking systems monitor aircraft positions in real time, enabling immediate emergency response when needed, dramatically improving survival chances compared to earlier aviation eras. The critical first minutes if ditching becomes unavoidable. Survival hinges on the crew's ability to execute emergency procedures flawlessly during those terrifying first minutes after impact. Flight attendants must quickly assess structural damage, locate usable exits, and coordinate passenger evacuation while the aircraft potentially floods with freezing seawater. Modern commercial aircraft carry comprehensive emergency equipment, including slide rafts that automatically inflate and detach from the aircraft, providing immediate flotation and shelter. Passenger survival depends heavily on following crew instructions precisely, securing life vests properly, maintaining brace positions during impact, and moving swiftly but calmly toward designated exits. Panic becomes the greatest enemy, as confused or frightened passengers can block evacuation routes and delay the critical transition from sinking aircraft to life rafts, where the real battle for survival truly begins. Surviving the open ocean. Once passengers reach life rafts, they face nature's harshest test: surviving in the open ocean until rescue arrives. Hypothermia poses the most immediate threat, as ocean temperatures rarely exceed 60 degrees Fahrenheit even in tropical regions, and the human body loses heat 25 times faster in water than in air. Modern life rafts include thermal protective aids, emergency food rations, and signaling equipment. But survival ultimately depends on remaining calm, conserving energy, and maintaining group cohesion. Search and rescue operations begin immediately when aircraft emergency beacons activate. But locating survivors in vast ocean expanses requires tremendous coordination between multiple agencies, aircraft, and vessels. Weather conditions significantly impact rescue time, and even with modern technology, survivors may wait hours or even days before rescue teams reach them, making those initial survival decisions absolutely critical for determining who lives and who doesn't. Psychological and physical challenges. The mental trauma of surviving an ocean ditching extends far beyond the physical ordeal of impact and rescue. Survivors often report intense psychological effects including post-traumatic stress, survivor's guilt, and persistent anxiety about future air travel. The human mind struggles to process the transition from routine flight to life-threatening emergency, and many survivors require extensive counseling to overcome the emotional aftermath of their experience. Physically, survivors face numerous challenges including saltwater exposure, dehydration, sun exposure, and potential injuries sustained during impact or evacuation. The combination of stress hormones, physical exhaustion, and harsh environmental conditions creates a perfect storm of health complications that can persist long after rescue, requiring specialized medical treatment and rehabilitation to fully recover from the ordeal. Lessons and future improvements. Every ocean ditching incident, whether successful or tragic, provides invaluable lessons that shape future aviation safety protocols and emergency equipment design. Investigators analyze everything from pilot decision-making processes to life raft deployment mechanisms, constantly refining procedures and technology to improve survival odds. Modern aircraft now feature enhanced emergency lighting systems, improved life vest designs, and more robust emergency locator transmitters based on lessons learned from past incidents. The aviation industry continues developing innovative safety technologies including automatic emergency descent systems, improved weather radar for avoiding severe turbulence, and enhanced communication equipment for maintaining contact during emergencies. While we can never eliminate every risk from flying, each technological advancement and procedural improvement brings us closer to ensuring that ocean ditching remains what it is today, an extremely rare event with surprisingly good survival prospects when executed properly. Data shows that survival rates for controlled ocean ditching have improved significantly over the past 2 decades, thanks to better crew training, enhanced emergency equipment, and more effective search and rescue coordination. Join the World Documentaries family by subscribing and hitting that notification bell to explore more fascinating stories about human resilience, technological marvels, and the incredible world around us. What would you do if faced with such an emergency? Have you ever experienced severe turbulence or aircraft emergencies? Share your thoughts and experiences in the comments below. Your stories help us understand the human side of these remarkable survival scenarios